Good morning and welcome to AP Statistics. Today I'm going to first go over the answers to the homework problems, and then we're going to focus for a little bit on question 73, which I want to help you walk through. So quickly, the answers to the multiple choice problems 71 through 78 were A, C, A, D, A, B, E. Hopefully you got them right. I believe they were all fairly manageable, but 73 stands out because you have to read what's called a Minitab Output. So let's take a look at the Minitab Output. On the board, or what will be on the board behind me, is just an excerpt from the book. All right, and hopefully we can read it, but I'm gonna zoom in through it a little bit for you. Okay, now, concerned with this side. 73 said, using data from the 2009 LPGA Tour, a regression analysis was performed using X equals average driving distance and Y equals scoring average. So we're trying to predict your scoring average from how far you can hit the ball. That's what a driving distance is. Using the output from the regression analysis shown below, determine the equation of the least squares regression line. Now here's the thing. They're giving you an output table from a program called Minitab. It is a data number cruncher, and very useful, and you'll see it a lot. Here's what I want you to understand. Some of the things here we won't be using yet. Some of the things here we might not use at all, but here's what they mean. This title says predictor. It's the constant, which hopefully is pretty obviously the A value in the LSRL. It's a constant. And the driving distance, which in this case is the variable. So it's going to be the variable, in this case, X. The coefficient of the constant is the constant. So the A value in the LSRL is 87.974. The coefficient of the variable driving distance is negative 0.060934. That's the B value in the LSRL. So, quick answer to the question, C, Y hat equals 87.9, oh, that's a typo, 974. I don't know which one's the typo, but it should have been 974. Minus, because it's negative, 0.060934x. That's the answer to the question. The coefficient is telling you the A and the B values. So with a Minitab output, that value, whatever values are there, are showing you the A and the B. The constant is obviously the A value, as it is the constant. And the B value is the coefficient of the variable, which is given to you as driving distance in this output. So that's the answer to the question, but let's move beyond that, okay? Look at the Minitab output. I want to explain some things. We already just explained what the coefficient column means. SE coefficient means standard error of the coefficient. Again, for right now, it's not going to be a major problem, but in the future, we use that when talking about making valuable predictions, especially using confidence intervals, which we'll do later, or hypothesis testing. T and P, for right now, they don't really have any special meaning to you. For what it's worth, the T score has to do with another distribution we're going to handle in like chapter, I think, 7. And the P is the P value, or probability of a value having been found. It's, again, for this problem, not a concern. This line is more of a concern. S is the standard deviation. Okay. The standard deviation is 1.01216. Now, what the standard deviation means with linear regression is it's the average distance from the predicted value to the actual observation. It's the average residual. Now, because it's standard deviation, it's always going to be a positive number, but it's the average absolute value distance to the line. So when I'm making a prediction of driving score, sorry, not driving score, when I'm making a prediction of your scoring average based upon the driving distance, I'm going to be wrong on average by about 1.01216, about 1 point. I'll be off by about 1 point. R square is obviously the R square value, and it's giving you the percent of the variability in the data. That's well explained by the linear relationship of driving distance on scoring average. Now, it's really bad here. It's 0.21 or 22.1%. That's terrible. That means only 22% of the variability is explained by this linear relationship. It's not good. What would the R value be given the R square? Well, I just need to take the square root of R square to find the R value. In this case, the square root of 0.221 is 0.4701. So what you're saying is the R value is 0.4701. That's a pretty weak, but positive? Well, when I take the square of something, it's going to be positive regardless. So is it a positive or a negative correlation? What can tell me that answer? This right here can tell me that answer. The sign of the B value is the sign of the slope. And the R value and the slope are linked in that way. So because it's a negative B value, this is actually a negative, pretty weak negative linear correlation. Important to note. Okay, well, what about R squared adjusted? We don't usually use adjusted scores. What adjusted scores are, basically we drop the extremes in the distribution. We just take the data points that are the lowest and the highest and say, maybe they were mistakes. And then we reconstitute our regression and we find out what the R squared would have been had we adjusted the data. As you could tell, it's not really much different. In fact, it got a little worse. It's 21.6%, so it actually didn't improve it to adjust those values. It made it worse. We usually are not going to use any adjusted values or what we call sometimes trim means. That means you're basically trimming off the lowest and highest numbers and refiguring the mean. We don't do that. All right. You're only ever going to do that if you were told to do that, and generally speaking, you're not going to be told to do that. So those are sometimes there as reported values, but not exactly something we're going to be using very much. Okay. So where do we go from here? Well, it's the end of the chapter, so we get ready for another test. What I want you to do is the attached worksheet, which is the Frappy from this chapter. You could use your book if you want to. It's page 199 through 200, but the worksheet, I think, makes it a little easier for most people. And I want that done and submitted to me by 7 a.m. tomorrow. If you have any questions, please let me know. And as usual, if you watch this before class, please log into the Meet. Otherwise, get to the work and let me know if there's any problems. Have a great day.